Right now, I have open the same competition template document that we created in the last video. It has all my motors and controller, and I have scrolled down to the user control section. Today, we're going to start by talking about a few simple commands for your robot. The first command is making the motor spin. To do this, type the name of a motor. I'm going to use my right wheel motor, and then dot spin, and then in parentheses you have to add the direction, forward or reverse. And then at the end of every single line in VEX code, you are going to add a semicolon. And now, when I run this code, my right wheel will spin forward. And it will spin forward at 100% of that motor's power. So it'll spin forward as fast as it can. But maybe I want it to go slower. Then I have to change the velocity. And there are two ways that I can do this. So the first way I can do it is change the velocity for the entire user control void. And to do that, I type the name of the motor I want, and then set velocity. And then I type in the velocity I want. So I'm going to say 30% of its maximum. Now, I can also change, instead of using percent, using rotations per minute, which can help you get really exact, but normally that's not necessary. And now this has changed the motor's velocity for the entire user control void. So when I tell the motor to spin again, it will spin not at 100% of its velocity, but at 30%. Now the other way we can change the velocity is we can change the velocity for only one line. And to do this, we add a few extra terms in our right wheel.spin. So we type that again, right wheel.spin, type a direction, and then we add the velocity. We're going to say 50%. And even though we already defined the right wheel's velocity up here, that will be ignored when it is running this line of code. But it's not exactly helpful to have your motors spinning infinitely. Sometimes you need them to stop. And it's simple to do that. Just type your motor's name, dot stop, and then some empty parentheses, because why not? And so now, our right wheel will spin forward at 50%, and then stop. But when you are using a motor to lift an arm, or to carry something heavy, and you just tell it to stop suspended midair, it'll normally fall back down. But we don't normally want that. So instead, we can do a number of things. We can either tell the motor to spin indefinitely at a very low velocity so that it counteracts gravity. So for example, I could say arm lift dot spin forward at 1.2% velocity. Or we can set the stopping mode. We can do that by saying the motor's name, dot set stopping. And then there's 3 different modes. You can tell it to brake, so it'll try to slow the slipping, or you can tell it to coast, or you can tell it to hold, where it won't move at all. I normally use hold because it's super helpful when I have heavy robotic arms that I don't want to fall down. So I'm going to click or type hold, and then my parentheses, and then my semicolon. And now that arm, no matter its position, will not fall down. Another helpful command, especially when coding an autonomous section of your code, is motor.spin4. I'm going to say right wheel is my motor. And we're going to say forward 3 turns. So now my right wheel will spin forward 3 rotations, and then it will stop. Now, given that I've just written this in the while one loop, which loops everything infinitely, this command will do the same as just telling the right wheel to spin forward. But when you write this in an autonomous section, which does not repeat infinitely, this is really helpful if you need your robot to turn just a little bit or to move forward a slight amount to a goal. You can easily measure out the distance that you need, and the robot goes exactly where you want it and no farther. Now, if you want to get really exact, you can also tell the motor to spin to a certain position. This can be really helpful for claws or lifting arms to a certain position on the robot. But before we can do that, we have to tell the motor what position it starts at. And we do this by defining the position of the motor. Now, it is really important that you make sure to define the position of your motor outside of the while one loop, because if you define it inside of the loop, it just keeps redefining. So if you say that the motor is at the position of 0 degrees, even if the motor spins, it will still think it's at 0 degrees. So make sure that you write this outside of the while one loop, and I'll say the claw dot set position to 0 degrees. And now the claw knows that its starting position is at 0 degrees. So, if I want to spin the claw motors to 90 degrees, I can say claw dot spin to position 90 degrees. And now the claw will spin to that position. So these are a few different commands that you can use to make your motor spin to certain positions or certain amounts, and to make them stop or break in a certain way. In the next video, we'll start working on buttons and joysticks and using if statements to gain greater control over your robot.